Good afternoon, everyone. My name is Yuan Zhixuan. I come from Zhixuan Jiaotong University, and I come from China. I am honored to have the chance to address you on this special occasion. The topic of my research is fractal characteristics of delay in a neural astrocyte coupling system. The outline of my talk as follows. The first part, I want to introduce the background of this research. The second part and the third is my two main results. Finally, a simple conclusion is given. In neural computing science, we will treat neuron as a simple electric circuit. From 1952, there are several neural models, like a HR model, are used to describe firing patterns of neurons. However, the number of glial cells is 10 or even dozens of times the number of neurons. Many physiological experimental results have verified that astrocytes play an essential role in communicating and regulating neurons, so it's vital to study astrocytes. This is a tripartite synapse with two neurons and an astrocyte. This structure is the most notable structure for exhibiting the relationship between neuron and astrocyte. Moreover, memory resistor oscillators is used to calculate the effect of magnetic flux. Yes, in this research, I add magnetic induction to the neural astrocyte coupling system. So consider the magnetic induced peripheral neurons. The keyword of this research is delay. Let's go to know what is delay. Here is a time history diagram of neural membrane potential. The first arrow means the moment of external stimulus stopped. External stimulus has been in existence from the beginning. That's to say, the moment a stimulus stopped equals the duration the stimulus continued. And then the second arrow is the moment firing of neuron stopped, the duration between two arrows, called delay. After stimulus stopped, electromagnetic field caused by neural firing inspire neuron in firing. Second part is about fractal induced by duration. This duration means stimulus duration. Here is several diagrams about different stimulus duration corresponds to different delay. Due to the different stimulus duration, delay will be different. Some delays are narrow, some are wide, and even some delays are zero. Even at a specific time, the second arrow did not appear. In other words, in this case, delay is zero. There are 6 neuronal firing patterns when the stimulus duration is approximately 20 seconds or 50 seconds. The difference is only 0.01 seconds from panel B to A and C, and from panel E to D and F. However, the delay appears from 0 in B and E, and TD equal 5.1 seconds in all 4 graphs containing delay. And in this 6 graphs, another interesting phenomenon is even change 0.01 second. The delay disappears and appears. And so I wonder if there is a rule. Here is the delay about stimulus duration from 0 to 60 seconds. And there are mainly 4 kinds of delay from 20 seconds to 60 seconds. They are 0, 2.8, 4.1, and 5.1. Even in a thinner interval, the 4 values could still be observed clearly in the interval 30 to 31 seconds. This clarity means, in other words, this clarity manifests the self-similarity. The self-similarity means the figure or the whole structure of it will not alter or change in a large or a short interval. A more familiar characteristic is scale-free. Self-similarity and scale-free are important characteristics of fractal theory. So the self-similarity can be quantified. The fractal dimension in fractal theory by double algorithm. It's the fractal dimension. One kind of fractal dimension is called Hausdorff dimension. Here is calculated as 0.9914. That is to say, this phenomenon does have fractal characteristic. And the third part is fractal induced by intensity. This is stimulus intensity. As the previous research here shows 6 graphs about the different neural membrane potential about different stimulus intensity. The delay is also affected by the stimulus intensity. Okay, as the previous method, the delay changed from external stimulus intensity from 0 to 40 shown here. The result here does not truly indicate that the delay equal 20 seconds in the interval 0 to 9.5. According to our definition, a negative delay is meaningless, as shown in previous PowerPoint. The neuron cannot fire continuous. Figure B, C, and D shows the fire patterns of the neuron in this part from 7.5 to 50. Indicate a different neural purging mode that switch frequently. Some negative values of delay reveal transient neural firing. In summary, when delay is negative, the neuron either fails to fire or experiences a short period of time from firing state to resting state. Of course, it's less than 20 seconds. The last interval from 15 to 40 shows the result similar to the previous phenomenon. Moreover, there are primarily 6 values in the interval 7.5 to 15 and 2 values from 15 to 40, which indicates the distribution of delay is obviously related to the select of interval. So the fractal dimension calculations is in different intervals, and the calculation method is the same as before. Its Hausdorff dimensions are 0.9837 and 0.966 respectively. Okay, here we can see this. The delay influenced by stimulus intensity is also have a fractal characteristic. Okay, we talk about the delay influenced by duration and intensity separately. And here I will show you the delay influenced by the two factors simultaneously. Here is the delay affected by the two factors. The diagram shows that delay is jointly influenced by these two factors. The gray and black area indicate values of delay outside of the range shown on the right. Special intervals are chosen for clear observation in the upper left corner. The value of delay is outside of the range. The largest value of delay in this area is about 17 seconds, and the smallest value is 0. Okay, here we can see the delay influenced by the two factors sensitively. Okay, another interesting phenomenon is the value of delay that appears most often is 5.1 seconds, and this can be more studied in my further research. And the last part is about conclusion. In a neural astrocyte coupling system, consider the magnetic flow delay depends on stimulus duration or stimulus intensity sensitively and show highly obvious fractal characteristics. And delay is affected sensitively by duration and intensity in the meantime, and also show highly obvious fractal characteristics. Thanks for your attention. That's all.